Have you ever really thought about what makes your phone smart or how your watch keeps track of everything? Well, today we're going to peel back the layers and look at the incredible magic happening inside all of our electronics. We're going from a simple grain of sand to the brains that power our entire world. So let's start with this. You've probably seen one of these little blue boards before. This is an Arduino Uno. For tons of people, this is the front door into the amazing world of electronics. It's simple enough for a total beginner, but it's also powerful enough for some seriously complex stuff, like controlling a robot or building a smart home. But here's the question. How does this thing actually think? How does it take a few lines of computer code and turn that into a real-world action, like blinking a light or spinning a motor? What's the secret sauce in there? All right, to answer that, we need to go on a little hunt. We need to find the brain of the operation. If you look close, yeah, right there, you'll see this little black chip sitting in the middle of the board. That is an ATmega 328P microcontroller. And that, right there, is the brain. Every single decision, every calculation, it all starts inside that tiny black square. So, what even is a microcontroller? The easiest way to think about it is as a complete, self-contained computer, but shrunk down onto a single chip. It's got a processor to do the thinking, memory to remember things, and ports to interact with the outside world, kind of like how our brains have eyes and ears and hands. But, believe it or not, we can go even deeper. To really understand how this brain works, we have to zoom in, way in. Because the real magic isn't the chip itself, it's the billions of microscopic little things it's built from. So let's meet the absolute unsung hero of our digital age, the transistor. And to understand why this was such a big deal, just look at this. On the left, you've got a vacuum tube. It worked, sure, but it was huge, it got super hot, it broke all the time, and it guzzled power. On the right, the transistor. It did the exact same job, but it was tiny, reliable, and barely used any energy. It literally changed everything. This world-changing moment happened all the way back in 1947 at Bell Labs. And these inventors, they didn't just create a new component, they basically laid the foundation for the entire digital world we live in today. Okay, so what does this little thing actually do? Well, at its very core, a transistor is just a switch, a really, really tiny switch. But here's the cool part. Instead of flipping it with your finger, you flip it with a tiny electrical signal. It can be all the way on, all the way off, or somewhere in between. It works using these three little legs or connections. You have the emitter, which is like the source of a river of electricity. You have the collector, which is where that river wants to flow to. And then you have the base. And that's the most important part. It's the gate, the dam that controls the whole flow. And honestly, this is the perfect way to think about it. Imagine a water faucet. The emitter is the main water pipe, the collector is the spout, and the base is the handle you turn. It takes just a tiny little bit of effort to turn that handle, but that tiny effort can control a massive, powerful flow of water. A transistor does the exact same thing, but with electricity. Okay, so we've got a tiny electrically controlled faucet. That's cool, but how in the world do you get from a single faucet to a brain that can actually think? Well, this is where it gets amazing. It all comes down to this incredible thing called amplification. You send a tiny little whisper of a signal to the base, that's you turning the faucet handle. That tiny signal opens the gate and bam, a much, much bigger torrent of current is allowed to just pour right through from the emitter to the collector. And that amplification factor has a name. It's called current gain. A typical little transistor might have a gain of 250. Now think about that for a second. That means for every 1 unit of electricity you put into the base, you get times 250 units flowing out of the collector. You're controlling a huge current with just a tiny one. And here's the really clever part. This one component can do two totally critical jobs. If you slam that faucet handle all the way on or all the way off, you get a digital switch. That's how you make the ones and zeros the fundamental language of all computers. But if you carefully control the handle somewhere in the middle, you get an analog amplifier, which is perfect for boosting weaker signals, like the sound from a microphone. So now, let's put it all together. What happens when you figure out how to make these switches microscopically small, and you pack not just one, but billions of them onto a tiny piece of silicon? Well, you get a microprocessor. You get a brain. You get a symphony of billions of tiny faucets all turning on and off in perfect harmony to perform complex calculations. And that brings us right back to where we started, to our little blue Arduino board. Because having a super powerful brain is one thing, but actually being able to use it, that's a whole other story. And this is the key distinction. That microcontroller chip is the raw, powerful brain. It's a genius, but it speaks a really complex language. The Arduino board, on the other hand, is the playground built around that brain. It takes care of all the boring, difficult stuff, the power supply to connections, and it just gives you this easy, friendly platform to start creating right away. And the beautiful thing is, it's a whole family. You have the classic Uno on the left, which is absolutely perfect for getting started. But when your ideas get bigger and you need more power and more connections, you can move up to something like the Arduino Mega on the right. And the ecosystem is just huge. There's the Lily Pad, which is designed so you can actually sew it into clothing for wearable projects, or the Nano, which packs a ton of power into a package that's smaller than your thumb. Whatever you can dream up, there's almost certainly a board ready to help you build it. So we've gone from a single tiny switch all the way to this incredible platform of possibilities. So what does that unlock for us? Well, it unlocks a whole universe of creation. We're talking about smart agriculture systems that water plants perfectly, home automation that turns on your lights when you walk in the room, educational robots that teach kids how to code, wearable health monitors that keep an eye on you, even mind-blowing interactive art installations. All of this is possible because that simple little switch was made accessible to everyone. So, the magic inside your electronics? It turns out it isn't magic at all. It's a beautiful, simple idea. A tiny faucet, scaled up billions of times. It's a testament to human ingenuity. And now that you know the secret, now that you know it all starts with one simple switch, the only question left is, what will you create?